Assalamualaikum. Hi guys, kita akan masuk new chapter 7, Haloalkanes. There are 2 subtopics in this chapter. We are going to go for the introduction first. In the introduction, we have to know how to give the name of haloalkanes according to IUPAC nomenclature, how to draw the structural formula for haloalkanes, and how to classify the haloalkanes into primary, secondary, and tertiary haloalkanes. So what is haloalkanes? Haloalkanes is a compound that contain halogen atom bonded to sp3 hybridized carbon atom. sp3 hybridized carbon atom means that carbon atom must have all single bonds attached to it. There will be 4 of it. And then the functional group for haloalkanes is halogen. It can be fluorine atom, chlorine, bromine, or iodine atom. The general formula for haloalkanes is RX. R means alkyl group, and this is the general formula for acyclic haloalkane or cyclic haloalkane. Acyclic ni maksud dia open chain. Tak kisahlah ada branch ke ataupun straight chain. Yang ini maksudnya dalam bentuk ring. And X can be these halogen atoms. Untuk haloalkane, kita kena tahu how to classify the class of haloalkane. So when you have classification of haloalkane, you have a few of it. So kita ada methyl halide di mana carbon attached to haloalkane, dia ada hydrogen all of it. You have to make sure that carbon contains sp3 hybridization. It means that carbon ni dia adalah sp3. And then next one, untuk primary halide, it means that carbon which attached to halogen adalah primary carbon atom. So this one adalah primary carbon atom. And then kita ada secondary halide, which is halogen attached to secondary carbon atom. And same goes for tertiary halide. Kita ada halogen attached to tertiary carbon atom. And then kita ada 2 jenis lagi, iaitu aryl halide. Aryl halide maksudnya halogen directly attached to the aromatic ring. Tapi kita ada lagi satu contoh, which is halogen attached to 1 carbon first, barulah carbon tu attached to aromatic ring. Ini kita tak panggil dia aryl halide, ini kita panggil primary haloalkane. Sebab this X is attached to 1 carbon atom, this carbon is primary carbon atom. So maknanya ini bukan aryl halide. Awak kena tahu cara untuk classify haloalkane kerana ini sangat penting apabila awak nak kenal pasti dalam reaction selepas ni. Now we are going to proceed with IUPAC nomenclature of haloalkane. When you want to give the name for haloalkane, you have to give the name as alkanes with halogen as substituent. So the same case as before, step 1 you choose the longest parent chain, but this one you should see that whether your longest parent chain is either open chain or cyclic ring. And after that, step number 2, if you got halogen atom, use it as prefix and arrange them in alphabetical order. So let's say I have A. Structure A, the longest carbon chain should be 4 of it. So I'm going to start from the left, 1, 2, 3, and then 4. So this is my parent, and after that I have Br is my substituent. So the name of this structure will be 2-bromobutane. However, you can also give another name for this one where your Br atom here is going to be the parent. We are going to use this one as bromide, and this structure is our sat-butyl. So the name of it can be sat-butyl bromide. So that is how you give the name for A. Now kita go for B. For B, what you have here is alkanes with the longest carbon chain should be 5. So I'm going to give the numbering. So this will be our numbering 1, 2, 3, 4, 5. And after that, we have 2 substituents here. The first one is Cl atom and the second one is methyl. So this is chloro, this is methyl. and both of them are at the same carbon atom, the third carbon. So when we want to give the full name, make sure you arrange them in alphabetical order. So I'm going to write as 3-chloro-3-methyl pentane. Next, we go for structure C. Structure C, the longest carbon chain should be in the ring. So you have the ring in 5 carbon atoms, and the first carbon should be at the one with more substituents. You can see this carbon got 2 substituents, 1 and 2. So I'm going to put this one as my first carbon, and then go here, you got third carbon for the next substituent. And then this one is what we call as methyl. This one is iodo, and this one is ethyl. So arrange them in alphabetical order. So I have 3-ethyl, and then -1-iodo, and then -1-methyl, and then my parent will be cyclopentane. So this is the name for structure C. Next, we have structure D. Here you have the longest carbon chain should be prioritized for alkene, where you have double bond here. So this double bond, I'm going to pick the longest carbon chain. I'm going to start from here and then go down here and here. So give the numbering: first carbon, second, third, fourth, and fifth. And then the double bond is at carbon number 2. And then you can see that we have bromo at carbon number 4. We have methyl at carbon number 3. So I'm going to write in alphabetical order. It can be 4-bromo, and then after that I have methyl at carbon number 3, 3-methyl, and then my parent is -2-pentene. However, if you look carefully, this drawing is just like V shape, horizontal V shape. So of course we should add something special where you can see this group opposite to one another adalah methyl, seolah-olah methyl. So kita boleh cakap ini adalah trans. So the name of the structure kena tambah trans dekat depan, barulah -4-bromo and so on. And then kita ada last structure, this one, where you can see that the longest carbon chain is our ring. And our ring, we have the first carbon here, second carbon, third, fourth, and fifth. After that, kalau kita lihat, kita ada substituents. Here is what we call as ethyl, here is methyl, and then kita lihat dekat sini very special, di mana what you have adalah chloro. Tapi chloro ni attach kepada carbon chain yang ada 2. So 2 carbon chain kita panggil dia sebagai ethyl. So this one adalah ethyl. And then kalau kita berikan nombor, chloro berada dekat carbon 1 of ethyl. So how am I going to give the name for this one? It's just like substituents in substituents. So we are going to write the bigger one. So this whole group here is the one that attached to the third carbon. So I'm going to write 3- and then kita letak dalam kurungan. What we have is chloro attached to ethyl, and this chloro is at first carbon. So I'm going to write 1-chloro ethyl. So itu adalah substituents yang pertama. And then after that baru kita go alphabetical order, iaitu ethyl kat sini. So ethyl is at carbon number 1. So -1-ethyl, and then we have methyl at the same carbon, and then the parent name will be cyclopentane. So you got the name for this structure E. So now I have 2 examples so that you can test the drawing. Actually, it's just a simple thing macam yang awak belajar dalam chapter 5. So we are going to draw the structural formula of haloalkanes. What we have here is 1,2-dichloroethane. So the parent for this one is ethane. So I have 2 carbon atom. So this is my first carbon, second carbon. And then what we have here, at each carbon, I have dichloro. So one here, Cl, Cl. So this is the structure for A dalam bentuk skeletal. After that, saya nak draw structure yang kedua. Identify the parent first. So my parent is cyclopentane. So I have cyclopentane like this one. And then give the numbering 1, 2, 3, 4, 5. And then at the second carbon, you have methyl. And then at the fourth carbon, you have chloro. And at the first carbon, you have bromo. So this is the drawing for structure B. Seterusnya, kita akan masuk bahagian terakhir untuk video kali ini. Macam mana kalau soalan minta awak untuk describe haloalkane as a compound that contain polar bond and the carbon bearing halogen are susceptible to nucleophilic attack. Apa maksud susceptible? Maksudnya dia more favor untuk diserang oleh nucleophile. So benda pertama awak kena cakap dulu reactive site dalam haloalkane. Reactive site dalam haloalkane adalah when we talk about the carbon atom attached to halogen. So this carbon atom yang directly attached to halogen adalah sp3 hybridise. This one. And then kalau kita lukis bentuk this carbon, memandangkan dia ada 4 single bonds, the geometry is tetrahedral. And then these carbon halogen bonds are polar because halogen is more electronegative than carbon atom. Kalau kita buat partial charge, kita ada partial negative for halogen, partial positive for carbon. So intermolecular forces yang exist between these molecules adalah van der Waals forces, iaitu kita ada dipole-dipole interaction because of this polar bond, dan juga kita ada London dispersion forces as well. So due to this partial charge between carbon atom and halogen atom, this partial positive carbon atom is exposed to nucleophilic attack. Kerana dia partial positive, dia lebih senang untuk diserang oleh nucleophile. Sebab itulah nucleophile, kalau kita ada dalam bentuk secara general, this nucleophile akan serang this carbon. Dan seterusnya, this bond akan beri sepenuhnya elektron kepada X. So di sini, you can understand that the type of reaction that exists in haloalkane can be nucleophilic substitution reaction dan juga elimination reaction. A bit special for haloalkane, dia ada 2 type of reactions yang awak perlu tahu. So I hope you can understand clearly what is haloalkane, how to classify haloalkane, how to write the IUPAC nomenclature, how to draw the structural formula of haloalkane, and the last one, how to describe haloalkane as a compounds which contain polar bond and very susceptible to nucleophilic attack at the carbon atom. So itu sahaja untuk video kali ini. I will see you in the next one. Bye!